In this video, we're going to look at a starred problem, 5.1.12. We will be computing the yield, or internal rate of return, in a new situation from the perspective of a borrower of a loan that's going to be repaid by a sinking fund with a variable interest rate. We'll take the opportunity to use the cash flow worksheet on a calculator again, and in fact, we'll also make use of something new, frequency values that are greater than 1. That will be a useful thing. As you can see here, we'll also take the opportunity to review what a sinking fund is here. That'll evidently be useful. And one more thing to review, we will review the formula for the accumulated value of an annuity immediate, which we have not used in a while. Now, before we look at the problem, you might wonder and try to answer the question of what would it mean to the borrower to compute the yield or internal rate of return for a loan? You're borrowing money. Isn't it the lender that's making money off of you? Well, the internal rate of return is the same from both the borrower's and lender's perspective, and it is still informative to the borrower because it tells them what kind of things they should do with their money to try to make the loan worth it. Okay, they're going to be paying a lot of interest here in this problem, so they better use their money wisely, use that loan money wisely, make some sort of investment in, well, the stock market or whatever, or maybe in capital in your business to make higher profits to justify taking this kind of loan. That's the practical way to view what's going on here. So here is the situation. We've got a loan of $100,000. It's to be repaid by the sinking fund method over a 25-year period. What does that mean? That means, to review, the lender receives annual interest payments at a rate of some rate, 10% per year in this case. 10% of $100,000 is going to be $10,000, so this is a pretty high interest rate that the borrower is paying. But it's just interest initially, and that has the benefit of freeing up cash for the borrower initially to invest in things, or invest in their business, for example. You probably would not want to do this if you are borrowing money to buy a home, though. The borrower is going to accumulate the principal to pay back the loan after 25 years in a final balloon payment by means of annual deposits into what's called a sinking fund. That's earning an interest rate that's not the same as the 10%, so that seems bad, but that's what the borrower can find evidently. It's earning an annual interest rate of 6%. However, after the 10th deposit, after 10 years, the sinking fund rate is increased to 8%. So this is a variable rate sinking fund. 6% for the first 10 years, and then 8% thereafter for the last 15 years. Now, before we look at parts A and B, it might be nice to draw a little diagram of what's going on here. It's important to think about this conceptually in this way, especially once we use the calculator. We've got the borrower over here and the lender over here. So those are two entities that are involved, but there's a third entity. There's this sinking fund, say that's down there. You've got the transactions going on. First of all, you've got the $100,000 payment from the lender to the borrower at time 0. 100K means 100,000, and that is occurring at time t equals 0. Then you've got the borrower paying the lender interest every year for 25 years. 10,000 is the amount of interest, 10% of 100,000. That's occurring every year at the end of every year for 25 years. Per year for 25 years. But those are not the only outgoing money from the borrower. There's also outgoing money from the borrower to the sinking fund of an unknown amount, question mark, every year for 25 years at the end of every year. That's per year for 25 years. And evidently, well, if you looked ahead, this amount could change in part A. Finally, at the end, it's not really the borrower who pays back the loan, it's really the sinking fund that pays back the loan. Okay, so there's 100,000 payment, 100K. That one's going to occur at time 25, at t equals 25. And that's important to realize here, that it's not going back through the borrower. So when you're thinking about the cash flow and calculating the yield or internal rate of return, that 100,000 at the end is not relevant to think about. Okay, you only think about the 100,000 at time 0, and then you think about the 10,000 and question mark values at the end of every year for 25 years. You don't think about this final amount at time 25 to pay off the balance. All right, now we're on to solving the pieces to this. Part A, at the time the loan is issued, the borrower is not aware of the future interest rate change in the fund from 6% to 8% at time 10. And based on assuming that the interest rate is going to stay at 6% for the full 25 years, he's going to make level deposits for those first 10 years based on that assumption. When the rate change is announced after 10 years, the borrower changes the level of the future deposits, the last 15 deposits, to still accumulate to $100,000 at the end of the 25 years. Okay, so evidently since the interest rate goes up, the payments for the last 15 years into the sinking fund will go down. The goal is to find the borrower's yield rate on this transaction, and again, the practical benefit of knowing that is to help the borrower decide what to do with the money, to justify the borrowing of the money. And if the borrower can't justify it, then probably this loan should not be taken. All right, part B, we're supposing that the rate change after 10 years is known by the borrower on the issue of date of the loan, and calculates a level deposits which is going to accumulate to $100,000 based on this knowledge, based on the 25-year schedule of interest rates, based on knowing it's 6% for the first 10 years and 8% for the last 15 years. We're still going to find the borrower's yield in this case, which again is still useful information for the borrower. After I solve these things with calculator help, I am also going to emphasize one more thing at the end, and we'll come to that later. Let's solve part A, though. Maybe you want to try to solve it without a number line, but I will draw a number line as I often do. In recent videos, we've drawn the cash flows on the number line. I'm not really going to do that here. Here I'm more thinking about the deposits into the sinking fund. And they are unknown, okay? Part of helping us find the yield is going to be finding these deposits. There's going to be a certain deposit X for the first 10 years, and that's going to change to some deposits Y for the last 15 years. Okay, we're doing part A. The borrower is not aware at first, but does change once the borrower finds out that the interest rate has changed. So X changes to Y, and evidently Y is less than X. That's what we should expect to happen. So the goal, before we can find the yield, is to find X and Y. So we got two unknowns, we need two equations. Think about how X is initially defined. The borrower was not aware. X was defined so that it would accumulate to $100,000 after 25 years, assuming 6% interest. It's an annuity immediate, so I use an annuity immediate symbol and a future value symbol S. 25 payments under the assumption of 6%, that was to accumulate to $100,000. Okay, that's an equation we can easily solve for X. Once we've got that, then we can solve for Y with the second equation. How can you find the second equation? Take all this money and accumulate it to time 25 under the assumption of 6% for the first 10 years and 8% for the last 15 years. So the X amounts for the first 10 accumulate to XS 10.06 at time 10, but then they have to accumulate to time 25 under 8% interest for 15 years. So multiply by 1.08 to the 15th. And then the Y values, 15 of those, have to accumulate to some amount, 15 payments under the 8% regime. And this is designed to accumulate to $100,000 at the time 25 as well. Okay? So let's now use the following formula I will write down. I usually don't write this down, but just to remind you, I'm going to use the formula for the accumulated value of an annuity immediate. SNI is 1 plus I to the n minus 1 over I. Just to remind you of that in case you've forgotten, since it's been a while since we used that. I'll use it in both of these equations here. Okay, so keep that in mind. So first calculate this thing with this formula. I is 6%, so I have 1.06 to the 25th power, n is 25, minus 1, divide by I, divide by 0.06, and I get this S to be 54.8645. I got to divide both sides by that to get X. So I'll take its reciprocal and multiply times 100,000. So X to the nearest cent, so to speak, would be 1822.67. I am going to carry more decimal places just to make sure I don't lose accuracy in the value of Y. So I'll go ahead and write down all these things here. I probably don't need to, but probably just a couple more would be good enough, but I'll write them all down. So that's the value of x. Plug that in to here now. Okay, let's go ahead and store this. Say in register 0. Let's find S10.06, 1.06 to the 10th power, minus 1, divide by 0.06, 13.18. I'll store that in register 1. Let's take 1.08 to the 15th, times what's in register 1, times what's in register 0. This quantity here is 76,209.03 approximately. I got to subtract that from 100,000, so I'll put a negative sign and then plus 100,000. Oops, must have made a mistake there. Forgot what it was. Sorry, I guess I have to redo things here. So 1.08 to the 15th power times what was in register 1 times what was in register 0. Subtract this from 100,000. I probably wrote the wrong number of zeros. 1, 2, 3, 4, 5 zeros. There we go. So now our equation to solve for y is y S15.08 equals 23,790.97326. I'll store that amount in register 0. Find S15.08, 1.08 to the 15th, minus 1, divide by 0.08. Take its reciprocal, times what's in register 0. Y is smaller than x. Y is 876.21 when you round it. Just in case, I'll carry more decimal places. Okay, we will need these numbers for the yield rate, which is now what I want to compute. I found x and y. That's now going to help me do what I want, find the borrower's yield rate for this transaction. Make sure you don't forget about the interest payments from the borrower to the lender. We've just found the question marks in the situation from the borrower to the sinking fund in the first 10 and last 15 years. So now we need the cash flow worksheet. So I can press CF for cash flow. It looks like it's zeroed out, but just in case, I can press second, and this one for clear work. Okay, CF0 is going to be the initial amount that goes to the borrower from the lender. That's a positive cash flow to the borrower, 100,000. Enter that. Tab down. C01, in videos to this point where we've used the cash flow worksheet, we've just treated this as the first payment. However, you can treat it as the first 10 payments in this case. The x values plus 10,000 with a minus sign. 10,000 plus 1822 is going to be 11,822.6718. Let's go that far. With a minus sign. That's going to go into C01, enter that. And now the frequency, make 10 instead of 1. We haven't made this something other than 1 before. But those 10 payments for the first 10 years will now go into F01. And then tab down the last group of payments, excuse me, the last 15 payments, y plus 10,000 with a minus sign will go into C02. So the value of y is here, add 10,000 to that, I'm going to get 10,876.21072, say, with a minus sign. Enter that into C02, tab down, F02 is 15. There's 15 of those payments. Enter that. Now we're ready. We will compute the IRR, and it should be correct. IRR, CPT, and this is indeed correct. That is the correct answer, and that does match the solutions manual. The solutions manual's made some mistakes recently, but this one is correct. The yield, or IRR, in Part A as a percent is 10.6012%. Rounded to that. Okay? So that's Part A, the answer. Now we'll go into Part B, which is a little bit quicker. Because now the payment is going to be level for the entire time. All 25 payments into the sinking fund are going to be the same. Call that level payment Z, say. There's just going to be one equation of value to solve for Z, but it is still a little tricky. We still have the 6% for the first 10 years and the 8% for the last 15 years. It's still a variable interest rate for the sinking fund. So we have Z, the first 10 payments accumulating to this amount at time 10. That needs to be promoted 15 more years under 8% by multiplying by 1.08 to the 15th. Then we have 15 of the last payments under the 8% regime. This has got to equal 100,000. Okay, so of course you can factor the Z out of that and write it this way. And then you can solve this for Z, figure out what this is, divide both sides by it, and then you've got Z. So let's do that here. Let's first compute 1.08 to the 15th. Store that in register 0. Compute this, 1.06 to the 10th minus 1, divide by 0.06 times what's in register 0. This quantity here is about 41.81. I'll store that in register 1. Now compute this, 1.08 to the 15th minus 1, divide by 0.08, 27.152. Add that to what's in register 1. Get this. This is what we have to divide by now. Take its reciprocal, multiply times 100,000. And I hope you guessed ahead of time that the answer for Z should be between X and Y. And indeed it is. Z is 1450.03559. And now we can use the cash flow worksheet again to figure out the yield rate. Go to the cash flow worksheet. I will go ahead and clear it out again, clear work. Once again, CF0 is the loan amount, positive, to the borrower, 100,000. Enter. C01 is 1450.03559 plus 10,000, don't forget about the interest, then with a minus sign, and with a frequency of 25. So we're going to have 10,000 plus this is 11,450.03559. Put a negative sign, enter, tab down, frequency is 25, enter, IRR, CPT, and that is the correct answer for part B as well. The yield, or IRR, is 10.5083%. Not too much different from the answer in part A. Okay, so it doesn't make a whole lot of difference. In either situation, you'd, as a borrower of this 100,000 loan, you'd want to have some investment, whether it's stocks or bonds or whatever, or an investment in your company where you are confident you're going to get returns higher than this to justify taking out a loan like this. Well, let me end the video just by encouraging you to check something else here to sort of re-emphasize that last point. Say we take part A, and we'd like to think about this in terms of investing. Investing at the yield rate, 10.6012. That 100,000 loan, if we imagine investing at that rate for 25 years, what will it accumulate to? It'll accumulate to 100,000 times 1.106012 to the 25th power. Okay, this decimal kind of got erased there. That's 10.6012%. Then 1 plus I is going to be that. This is going to be, if we can find that kind of investment, what this 100,000 loan will accumulate to. 1.106012 to the 25th power. Oops. To the 25th power is that times 100,000. We're over a million. 1,241,640.80. Another way to think about this IRR, this yield here, is that if you invested X and Y in the same account, it should accumulate to the same amount over 25 years. So I'll leave it to you to check based on this value for X and this value for Y, that X S10.106012 times 1.106012 to the 15th power plus y S15.106012 will accumulate to the same answer. Okay, I'll leave that for you to check based on this x and this y, and you'd probably want to use all those decimal places to get it to be reasonably close, hopefully to the nearest cent. Okay, so that would justify this point of view that I said as far as how to understand the yield rate.